Hello. So today we're going to talk about energy diagrams. This is actually going to be part one of two lessons that have to do with energy diagrams. Today your focus is going to be on describing the enthalpy of a reaction. So we're going to talk about what enthalpy actually means. We're going to review endothermic and exothermic reactions. We're also going to be talking about table I. So in addition to your notebook and something to write with, you are going to need to be able to see table I in your reference table. The second lesson, which should be out soon, is going to be actually labeling what's called an energy diagram. So today, most of the terminology we're going over actually has to do with labeling an energy diagram. Let's start with a little bit of review. So the chemical reaction here is between methane and oxygen, and hopefully you remember what type of reaction this is. But my first question is this reaction exothermic or endothermic? And question number 2, having to do with the previous lesson, explain in terms of collision theory why a lower concentration of oxygen gas decreases the rate of this reaction. Let's talk about the first question. So is this reaction exothermic or endothermic? Remember that exothermic means heat is exiting. We're losing heat, or heat is being released. Endothermic means heat is being taken in. So if we look at this equation, heat is represented by kilojoules right here. Sometimes you'll see another symbol for this, but we'll go over that in a minute. But heat is on our product side, so heat has been released from the reaction. This is exothermic. Question number 2, explain in terms of collision theory why a lower concentration of oxygen will decrease the rate of reaction. If we have less particles, so remember collision theory has to do with particles. If we have a lower concentration, we have less particles of oxygen, which means we have less effective collisions, which decreases the overall rate of the reaction. Alright, so energy changes in a chemical reaction. Again, some of this is review, but I would still like for you to write it down. All chemical reactions are either going to absorb or release energy, meaning they're either classified as endothermic or exothermic. If we have an endothermic reaction, energy is absorbed. This means the products end up having more energy than the reactants. This is going to be important for part 2 of the lesson. Exothermic, energy is released, like we just saw in the do now, meaning products are going to have less energy than the reactants. We can show this using what's called an energy diagram, which we will be looking at in our next lesson. Here's a major point of today, enthalpy. So enthalpy is a fancy term for meaning the total amount of energy in the system. When I say the word system, I can mean what's the total amount of energy in our reactants, what's the total amount of energy in our products, how is energy changing throughout a chemical reaction when it goes from reactants to products. H is the symbol for enthalpy. So when you see this, delta H, if you remember delta from when we talked about Q equals MCAT, this means change in. So delta H represents the change of energy in a system. In this case, we're talking about a chemical reaction. Delta H is referred to enthalpy or the heat of reaction. So you're going to have to be familiar with both of those terms. Delta H is enthalpy or heat of reaction. Delta H, again, it means there's a change in. So this is what it represents in a equation form. Delta H is products minus reactants. This is a must know right here. Delta H, so if we're looking for the heat of the reaction, it is the difference in enthalpy of the products and the reactants. If you have a positive delta H, this means energy is absorbed, so you have an endothermic reaction taking place. If you have a negative delta H, that means energy has been released, so an exothermic reaction has taken place. This is kind of a must-know slide right here. So you need to know delta H is products minus reactants, a positive delta H, endothermic reaction, negative delta H, exothermic reaction. And one last little recap here. Endothermic and exothermic chemical equations. Endothermic, if energy is being absorbed, it means energy is going to be on your reactant side. Energy is being absorbed into the reactants. Again, this could be represented by the term energy. It could be represented by heat. It could be represented by the kilojoules like we saw in our do now. Exothermic releases energy. Energy is going to be a product. Now what I would like for you to do is get out your reference table and turn to table I. Alright, so let's take a look at table I. This is what it should look like in your reference table. So we have a whole bunch of chemical reactions listed. And we have their delta H values. So again, delta H, it's an energy term, which is why the unit is in kilojoules. And this is the amount of energy it takes for that reaction to occur. So again, negative delta H's, these are all exothermic reactions. A positive delta H indicates an endothermic reaction. And there's even a little reminder here down at the bottom. The delta H values are based on molar quantities represented in the equations. A minus sign indicates an exothermic reaction. So it's super important to understand that the minus sign is exothermic. Heat has been released. Here's an example question based on table I. So given the equation, 2 carbon monoxide plus oxygen gas create 2 carbon dioxide. What is the heat of reaction in kilojoules when 2 moles of carbon dioxide is produced? So let's find the equation. Here it is. And we can see that when 2 carbon dioxide are produced, the delta H value is minus 566 kilojoules. This was multiple choice. That's the value you would pick. Sometimes, I should say question number 2, but sometimes it gets a little trickier than that on the Regents or your upcoming test. What is the heat of reaction in kilojoules when 1 mole of carbon dioxide is produced? So we would still go and find that same equation. But when 2 moles is produced, we see negative 566 kilojoules is produced. If only 1 mole is produced, we have to cut that in half, and it would be negative 283 kilojoules. These are pretty much the only types of questions that show up from table I. I do think it's super useful that down here it tells you that a delta H value that's negative is exothermic, but keep in mind that you have this information available to you. All right, a little bit more terminology. Activation energy. In order for a reaction to occur, an activation energy has to be produced, reached, however you want to phrase it. But activation energy is the minimum amount of energy required to start a reaction. So every chemical reaction requires a little bit of a spark, so to speak, of energy in order for it to proceed. The more energy needed to start a reaction, the higher the activation energy is, the slower the rate of reaction for that chemical reaction. It slows the rate because more energy is required in order for the reaction to go in the first place. The symbol for activation energy is this, E with a lower subscript of A. In a chemical reaction, there's also something called an activated complex. Sounds complex, but it's not. It's basically the highest energy state during a reaction. So there is a moment when a chemical reaction is occurring where the bonds of all your reactants are being broken and the new bonds for your products are being formed. When your reactants and products are in that intermediate state, that is called the activated complex. that is going to be all for today's lesson. Stay tuned. We're going to talk about energy diagrams. We're going to take a look at exothermic and endothermic energy diagrams, and we're going to label them with all the vocab words that we just learned in today's lesson. If you have any questions, let me know. Have a good one.